really to die at that time.
Could he blink his eyes or move his mouth in any way?
He could blink his eyes. He had some limited mouth movements, but couldn't produce any intelligible speech. It was like completely slurred and incomprehensible. He survived this injury. A lot of people who have that kind of stroke just don't survive. The way he actually communicates, because he has a little bit of residual neck movements, is that he improvised and had his friends basically put a stick attached to his baseball cap. And because he could move his neck, he would essentially type out letters on a keyboard screen to get out words. In fact, this is how he communicated, was through a device that he would essentially peck out letters one by moving his neck to control this stick attached to his baseball cap. He hadn't really spoken for about 15 years.
Oh, goodness.
Yeah. So it was part of a clinical trial. It was, something that our hospital and also the FDA, had to approve and looked at very carefully. But given a lot of the work that we had done, there was some basis for why this might work. And so we did a surgery where we implanted electrodes onto these areas that control the vocal tract, the areas that control the larynx, the areas that control the lips and tongue and jaw movements when we normally speak. These are areas that presumably may be active. That was our hope. And he underwent a surgery, a brain surgery. We put an electrode array and we connected it to a port that was screwed to his skull. And the port actually goes through his scalp. And he's lived with this now for the last 3 years. So he has an electrode array that's implanted over the part of this brain that's important for speech. It's connected to a port. And then we connect a wire to that port that translates those, what we call analog, brain waves, and converts them into digital signals. We put them through machine learning or artificial intelligence algorithm that can pick up these very, very subtle patterns. You can't actually see them with your eye in the brain activity and translate those into words. And this is something that took weeks to train the algorithm to interpret it correctly. But what was incredible about it was to see how he reacted. He would be prompted to say a given word like, outside, for example. And then he would think about it, try to say it, and finally those words would appear on the screen. And what was really amazing about it was you could really tell that he got a kick out of that because, his body would shake in a way and his head would shake in a way that he would start to giggle. That was cool to see. But then I also realized that when he was giggling, it kind of screwed up the next word's decoding.